Hello and assalamu alaikum everyone. In today's lecture, we're finally moving on to break-even chapter, the break-even part of this chapter. So we're going to talk about break-even, contribution, how do we draw break-even chart, and if we have time, how do we use that break-even chart as well. So without further ado, let's begin. Break-even, it can be defined as the level of output at which total cost equals total revenue. That means that level of output where neither profit nor loss are being made. Now if you know profit or loss, we calculate the profit or loss by total revenue minus total cost. So whatever the revenue that is generated and whatever the cost you have incurred, we just subtract both of them and you see okay how much profit you have made or how much, and if the answer is negative, that means you have made a loss. A break-even chart shows fixed costs, total costs, sales revenue, and margin of safety sales in addition to the break-even point. So all these information are shown in the break-even chart. So how do we calculate the break-even without the chart? We can calculate it using the formula as well. That is fixed cost divided by selling price less variable cost. So this selling price less the variable cost is also known as contribution, that how much each unit contributes towards a certain product. So do know that break-even is used for one product at a time. So the selling price is per unit product, same goes for variable cost per unit, and then you just subtract both of them to see how much contribution is made per unit, and fixed cost is of course fixed, so fixed cost divided by that contribution per unit, that will give you the break-even output. And if you multiply that output with your selling price, you can get your break-even sales. So contribution, it can be defined as a difference between sales revenue and variable cost of production. As we can see over here, that sales revenue and variable cost. Contribution per unit is the difference between selling price and variable cost per unit, that is selling price minus variable unit cost. Contribution basically informs how much each unit sold contributes towards covering up the fixed cost of the business. So how much does one unit contribute towards covering up the fixed cost? Is it like, it's just that, okay, so let's say we have a product that is sold at $60 and variable cost is $30, so 60 minus 30 is $30. So each unit contributes $30 towards covering the fixed cost, which is, let's say, 30,000. So 30 unit is contributed by each product. And how many products do we need to cover up the 30,000 fixed cost? We need 30,000 divided by 30, that is 1,000. 1,000 units need to be sold in order to cover up the fixed costs and reach the break-even point. Once these fixed costs are paid, contribution provides business with its profits. So after you have reached the break-even point and if you make further sales, that means you have passed on the break-even point, you have covered up the fixed cost. Now you go on to make a profit. Before covering up the fixed cost, you are making a loss because you have not covered the fixed costs yet. After you have paid for the fixed costs, then that means you can start making a profit. So first it was used to meet fixed costs, and after those are met, there are no other costs left. So contribution then contributes towards earning profit. Now some of you might say, how are there no other costs left? We also have variable cost. Well, variable cost is included in contribution. Like contribution is basically selling price minus variable cost, so variable cost is already covered in contribution. Fixed cost was not covered, but it eventually covers that. First meets the fixed cost, and after it has met the fixed cost, that means there are no other costs left to cover, and hence contribution contributes towards earning a profit. The basic, so if you know that contribution is selling price minus variable cost, you can also write break even as fixed cost divided by contribution, since contribution is equal to selling price minus variable cost. Just a little more different formula as well, but the answer will be same. Moving on, now we are going to look at how do we draw a break-even chart. So what is the information that we need to calculate the break-even level of output? Well, we need to know the selling price of the product, the variable cost of producing a single unit of the product, and the fixed cost associated with the product. So we need all these, both of these costs and the selling price of the product as well. And also we also need to know how much sales are being made, so the output, the maximum output that the user thinks they can handle. So in our example, we're going to use the following data. We are going to use that fixed cost as $10,000, variable cost per unit as $35, selling price per unit as $30, and the maximum output that this business was going to produce is 750 units. So drawing break-even charts. Before moving on to drawing break-even charts, I'll give you a brief overview of what is required in our syllabus. In our syllabus, we just need to know what is break-even chart and like how do we draw and interpreting a break-even chart. You don't always need to just draw it. You won't be asked to draw it either, but it's a good practice to know how do we draw it so that you can easily interpret break-even chart if they give that in exams. So let's just have a quick walkthrough of how we draw it. First, we draw the axis. Of course, the x-axis represents the output level, so how much sales are being made, and the y-axis represents price used for both revenue and cost line. So here I've made my scale over here. I made 10 divisions, 1 2 3 4 5 6 7 8 9 10 divisions, 7.5 per each, and 7.5 basically means this scale is given as 10 units. So 7.5 multiplied by 10 means 75 units, and 75 minus 10 is 750 units. That is our maximum output, right? And then we have a price. How do I make this price factor, this axis? I just calculated the maximum revenue, because the revenue will of course be greater, or maximum cost as well. Maximum revenue was just $60 multiplied by maximum output. That gave us $45,000. 45 and multiplied by $1,000, that will give us $45,000. So this is the maximum point. And as for the cost, that will be fixed cost plus total variable cost, so $35,000 multiplied by $750 units. That answer plus 10,000, that will be your total cost, and that was somewhere around, I guess, here somewhere. So yeah, let's move on. We have drawn the basic axis first, then we draw a fixed cost line. We start drawing with fixed cost line. Since the fixed cost line does not change with the output level, fixed cost is shown as a horizontal line. We know that it does not change, so we don't draw a line like this or this. No, we know what is the fixed cost. It's $10,000, so we just draw a straight line at that point. Do note that the graph shows that fixed cost is incurred even when there is no production taking place. That is, the output level is 0. So over here, this point is of course stating the origin. So over here, you can know that the sales are 0. Okay, but there is still a cost at 0. When you have 0 sales, there is still a cost which is $10,000 that is a fixed cost. Okay, so just keep that in mind. Next, we have to draw other lines. We need to have 2 points on graph and join them together. Fixed cost was a horizontal line, so we did not need 2 points. We just needed to know the cost, and we just made a point at 10 0. Then the cost was same, so we just made a horizontal line from 0 sales to maximum output. Okay, but now for all other lines, they are not constant, they do change with output, so we need 2 points for that. Variable costs are generally not a requirement, but drawing it aids in making a more accurate total cost line. So it is preferred that you draw variable cost for making the total cost line, and you can erase it after you're done drawing total cost line. As for the 2 points we need to make variable cost line, we'll use the origin and the maximum variable cost. So variable cost, total variable cost, we don't necessarily have to make it, and even if you make it, you have to erase it when you are finally done with your chart. But we do need to know the total variable cost in order to make the total cost. Like, it's a good practice, because total variable cost, the total cost is what? It's the sum of total variable cost plus fixed cost. So it's going to be the same shape as the total variable cost, just it's going to start from here and then go up to here. It's going to be like, for each unit it's going to add 10,000 to it, so like from 0 to 10,000 over here. So at 30 it's 10,000 plus 10,000, 20,000, it will be over here. Okay, so that's why we need to have total variable cost, so we can have a better representation. The 2 points that we needed for total variable cost, first is the origin, that is, it shows variable cost when no sales are made, which is equal to 0. Sales are 0, variable cost is also 0. Maximum variable cost, which shows variable cost at the maximum output, which can be found by calculating the product of variable cost per unit and maximum output level. So we just found that like $35 per unit is the variable cost, and maximum output level was 750, so $35 multiply by 75,000 gives us this value, which is some roughly around 27,000 something. Now this scale is not accurate, so I can't pinpoint the value right now, but of course when you have it on graph, then you can easily pinpoint the value. We joined both these points to make variable cost line. So this point was joined with this particular point, and we had a total variable cost line. Moving on, we need to have a total cost line. Total cost line is basically the sum of fixed costs and variable cost line. So it can easily be drawn by adding both components when output level is 0 and when it is maximum. So we just add the total cost, total variable cost and total fixed cost at both points. So over here 0 plus 10,000, it's 10,000, and then over here 10,000 plus whatever the value was like 22,000 something though. 10 plus 20, sorry, 27,000 something. So 10 plus 27,000 is like 37,000 something. So that's why it's over here. And we just join both of these points. We have our total cost. Do know that 0 output level total cost is equal to fixed cost, as variable cost is 0, which we can see right over here. And at maximum output level, total cost is equal to the sum of fixed cost and the maximum variable cost. Okay. And if you are familiar with mathematics, total cost line is basically the horizontal translation of variable cost line up by fixed cost. As you can see, they are both similar shape, but it's just added by it's like a horizontal translation by fixed units, fixed cost, right? See, if you just calculate the difference between both of these, it's always going to be 10,000 at any point. Okay, so after we have drawn our total cost line, we just erase the total variable cost, and our graph will look something like this. Do you see? Okay, we have a fixed cost, we have a total cost, the total variable cost is now removed. Next, what we need is the total revenue. Finally, we need to draw our total sales revenue line. The 2 points we'll use are origin, of course, since no revenue earned when no sales are made, and we also need the maximum sales revenue, which is the product of selling price per unit and maximum output level. Sorry, I'm still point over here. Yeah, all good. So selling price was $60 per unit. $60 multiplied by 750 gives us 45,000, and that's what this point is, the maximum point. The origin point is of course here. So origin to maximum point, we draw a straight line, that gives us a total revenue line. Okay, and now after drawing this, our graph is complete. We have total revenue line, we have total cost line, we have fixed cost line, and this point, this particular point where your total revenue intersects the total cost line, that means both of total revenue is equal to total cost. So therefore this point is known as your break-even output or break-even point. And of course I can't pinpoint the value, exact value over here, but we can do that when we have a graph. So just a representation and example of how we draw it. Okay, so we can also use, how do we use this value, this break-even chart? I'm going to cover that in the next video since we are out of time. So thanks for watching, and Allah Hafiz.